Okay, we just went over all of the equations for the front of our packet, and we're going to do question 1.1 together. All right, let's take a look at this question. Number 1.1, when the rover Sojourner was deployed on the surface of Mars in July of 1997, radio light signals took about 12 minutes to travel from Earth to the rover. How far was Mars from Earth at that time? And then we have an answer that's written in scientific notation, so it's going to take us a minute to make sure that we have all of this information. So let's take a look. I could only find this paper at home, so I'm sorry it's not my usual lined paper. So 1.1, we're making our given and find chart. That T-chart is a must every single time. Stay organized, and then that way you're going to have a much easier time solving for these problems. It's talking about the name of the rover. We don't care about that. It's talking about it's going to Mars. Don't care about that. It's talking about the year, 1997. That doesn't matter either. But what does matter is we're talking about radio signals, which is a light wave. If we're talking about a light wave, we know something about light. We know a constant number about light. Let's flip back over to the front of our packet. Look at this packet. Take a second. What is a known number or a known constant about light? If you're looking at your variable and units column, you're going to notice that we know the speed of light in a vacuum, which is space, 3 times 10 to the 8th meters per second. So that's what we're going to write in our given column. This was something that was given to us, maybe not directly, but they did remind us that we were talking about light here. So we're definitely going to be using this number. 3 times 10 to the 8th meters per second is our speed of light. Now that's usually the letter C, but could we also use the letter V here? Absolutely, okay? Remember, physicists just like to use a lot of variables. We like to make sure we use all of the alphabet and the Greek alphabet. So C is just the variable that we've used to represent the speed of light, but it is also the same as the letter V for velocity. Another thing they gave us was time. They said our time was 12 minutes. Now they said it took about 12 minutes for those radio signals to travel from Earth to the rover. All right, so here's Earth. We got our, different pieces of land, whatever. Okay, here's Earth. And here's the rover. I'm just going to put a little star over here because I'm not going to draw Mars. This right here is a distance, D. Now the signals traveled from here all the way to the rover in 12 minutes. It took 12 minutes for it to get there. And we know the speed. The speed is the speed of light. Okay, so the velocity that the light waves were traveling with was C, and the time it took was 12 minutes. What are we trying to find here? It says, how far was Mars from Earth at that time? We're looking for D. Now tell me, if you look at the front of your packet again, which equation are we going to use? It might be a little confusing at first because I did write the letter C here, but I'm going to tell you we're not using the period equation. This has nothing to do with the period. We're not using the frequency equation. It has nothing to do with frequency. We don't care about the relationship between those two variables either. It has to be either the speed of light or the general speed equation. It has to be one of these two equations. Which one do you think it is? The general speed equation is the one we're going to use. We're not using the speed of light equation because we don't have frequency. We don't have wavelength. Those are two unknowns. You can't have an equation with two unknowns and solve it, okay? You'd have to have two equations with two unknowns. Then you could solve it, but we would only have one. We're going to use this bottom equation, the general speed equation, because we do know the speed of light. And yes, it's supposed to be a letter C, but like I said, we can use the letter V. We also know the time, and we're trying to find the distance. Can we solve this equation if we have 2 of the 3 variables? Absolutely we can, okay? So we're going to write this equation over here. V equals D over T. But there's a problem first. We need to fix something in our given column. What is the problem with one of my variables in the given column? If you're thinking that time can't be in minutes, you're right. We do not measure time in minutes. We need to convert that to seconds. So first I need to convert my time. Again, I apologize for my messy handwriting. Okay, when we're doing conversions, remember we're using that picket fence method. We're going to write what we have, 12 minutes over 1. There's my picket fence. I just set it up. So I've got my fence. My first picket is down. I'm trying to go from minutes to seconds, and this is something that's ingrained in your brain. You don't need your gold sheet for this one. How many seconds are in 1 minute? 60, right? But how do we write that as a fraction in our next picket fence, okay? So now I put my picket here, and I need minutes to go away, and if you recall, if minutes is going to disappear and it starts on the top, that means we need to put minutes on the bottom, okay? Those units have to cancel, and they're not going to cancel if they're on the same part of the fraction. They have to be on opposite sides. So this minutes is on the numerator part, so we're going to put minutes on the denominator of the next fraction. If we were to put it on the numerator, that would become minutes squared when we multiply across, and we do not want that, okay? So in 1 minute, there are 60 seconds. And minutes is going to cancel. Seconds is what I'm looking for. So I made my picket fence a little too long. I'm going to erase the extra. I'm going to put my equal sign right there. And now I'm going to multiply these 2 fractions. These 2 fractions are multiplying straight across. 12 times 60. I'll grab my calculator. 12 times 60, 720. And there's nothing on the bottom that I need to divide by because 1 times 1 is just 1. So my answer is 720 seconds. Instead of 12 minutes, I'm going to use the number 720. Okay? All right, so now that we've converted our time to match the units that we need, now we can plug it into this original equation. So again, it's V equals D over T. What am I going to plug in here for V? So technically V is c, the speed of light. I'm going to write 3 times 10 to the 8th meters per second. I'm going to plug that in on the left side of the equation, and I'm going to write the equal sign right next to it. Plug it in just how you see it. What do I substitute in for D? Remember, D is what we're solving for. So we're going to leave it as the variable D because that's what we're solving for. That's our unknown. And then lastly, what do I plug in for T? Yep, 720 seconds. That's my time. Now, here's the question. In algebra, if I am taking D and I want it to be by itself, I have to get this 720 to the other side. Well, D is being divided by 720. What's the opposite of dividing? Multiply, right? So to get 720 to the other side, I have to multiply by 720 on both sides. That's going to cancel, right? So, and remember, we always write our variable on the left. D is equal to 720 times 3 times 10 to the 8th. These two numbers multiplied together are going to give me my answer for my distance. So I'm going to take my 720 from before, I'm going to multiply it by 3, shift log, remember, that's what we have to put for our times 10 button, to the 8th. Why is this not working all of a sudden? Times 3, shift log, there we go. I guess I just have to push harder. 3 times 10 to the 8th, okay? This is how we put in our scientific notation. We've done this before in the past, and we're going to click equals. 2.16, and then don't forget this times 10 little thing right there. You got to pay attention. It's very small, to the 11th power, 2.16. So D equals 2.16 times 10 to the 11th, and our unit is meters. Let's double check our answer with the answer from the packet. And you know that sometimes there are some typos, so if you ever feel like, oh, there might be a typo, then let Miss Davis know and she will ask me and I will double check. But 2.2 times 10 to the 11th is the same as 2.16. It's just rounded up. 2.2 is 2.16 rounded up. Okay, same answer, perfect. We're going to box our answer, and that is our answer for 1.1.